Welcome to the unit third of the machine drawing, riveted joints. So the riveted joints are the permanent fasteners. So unlike the threaded fasteners, which is temporary fasteners, the riveted joints are permanent fasteners, and rivet is one of the commonly used method of producing rigid and permanent joints. So here permanent joint means what? Once you join these components or any parts with the permanent fasteners, you cannot remove it for any construction or rework purpose. If you want to remove means you need to destroy it. For example, welding is also a permanent joints. So if you want to remove the joints, welded joints, then you have to break that weld. Similarly, the riveted joint also, if you want to remove the joints, then you have to break it, so it will be destroyed. So that's why it is called as permanent joints. The types of the riveted joints include lap joint and butt joint. So here comes the basic construction of a rivet. It consists of a head and the shank portion, which is specified by the diameter D, and the tail portion. So these are some formulas which comes when you are designing the riveted joints, which includes the diameter of the rivet is given by the formula D equals to 6 root T, where T is the thickness of the plate, which will be given in the formula, which will be given in the problems. So the longitudinal pitch P equals to 3 times the diameter. So margin M equals to D. The distance of the center of the rivet to the edge of the plate is 1.5 times the diameter. The transverse pitch for zigzag is 0.6 P, and for chain it is 1.8 times the pitch. So thickness of the single cover plate T1 equals to 1.125 T, and the thickness of the double cover plate equals to 0.7 or 0.8 T, and the diameter of the snap head is 1.6 times the diameter, and the diagonal pitch PD equals to 2 times the pitch plus D divided by 3. So these formulas will come for all the riveted joints, which include lap joint, butt joint, single cover plate, a double cover plate. So today we'll solve the simple problem on a single riveted lap joint of thickness 9 mm. So the thickness of the plate is given as 9 mm. So initially in any problem, the thickness will be given. So by using thickness, you have to solve the other formulas here. So here the diameter of the rivet is given by the formula D equals to 6 root T. So the answer will be 18 millimeter. If you substitute the thickness as 9 mm, you will get 18 millimeter. Similarly, the longitudinal pitch, the P equals to 3 times the diameter. So we got it as 54 millimeter. 3 times the 18 is 54 millimeter, and the margin M is equals to diameter, that is 18 millimeter. So we got 18 millimeter here. The distance of the center of the rivet to the edge of the plate is given by the formula 1.5 times the diameter, that will be 27 millimeter, and the radius of the rivet head equals to 0.8 times the diameter, that will be 14.4 millimeter. The height of the rivet head is 0.7 times the diameter, that will be 12.6 millimeter. So we are using, for the syllabus point of view, we have the snap head rivet head. Snap head rivet head we are using. So these are some formulas which we have discussed earlier. This is 1.5 D. This is the distance from the center of the rivet to the edge of the plate. This is 1.5 D. This is here, the D is the diameter of the rivet, and this radius is the radius of the snap head or rivet head, and this is the thickness of the plate, and this is the pitch, the distance between the center of the two rivets, which is the pitch here. So let us solve this problem. So you have to draw this single riveted lap joint in the drawing sheet. Today I will draw this in Solid software. The procedure remains same. So what the procedure you need to follow here, the same procedure will be followed while drawing it in the drawing sheet. You need to capture the procedure what I will tell here. The same procedure will be followed in while drawing in the drawing sheet. So let us start this with the center lines. I will draw a center line here. Similarly, you have to draw a center line in the drawing sheet. So now the thickness of the plate is given as 9 mm. So draw a 9 mm plate thickness, and the center, this is the center of the rivet head. So the distance, the center, the rivet head to the edge of the plate is 27 mm, that is 1.5 D. So to draw a 27 mm line here, from here 27, and the thickness of the plate is 9 mm. So 9 mm will draw. Another 9 mm plate, two plates are there, so draw the another 9 mm plate here. The length of this plate is, you can draw for any line, any length. So there is no any specific length for this. So you can draw any line and draw the section here at the end, so that it will show that it is of sectional part. So you can draw for any length here. So you have to draw the section lines, so that it is not having any particular length. This part is having the particular length, that is 1.5 times the diameter. So now you have to draw a 10-degree taper line from here. Is the remaining portion. This is not required. Similarly, you have to draw it in the drawing sheet. What is the procedure I am telling you? Similarly, you have to draw it in the drawing sheet. So now, draw this side lines, that is 27 mm. From here to draw 27 mm, that is 1.5 D dimension. Now you draw the 10-degree taper line here. And thickness of this plate is 9 mm. You join here. This portion you erase it. So upper portion is having infinite length, so you can draw it for any length, so that you show the section here. You can draw it this length for any length. So these are two plates now. Now you have to concentrate on drawing the rivet. So the diameter of the rivet is, we got it as 18 millimeter. So I will draw 9 mm from here. This is the 18 mm here. This is the diameter of the shank portion of the rivet. So now you have to draw the snap head. The radius of the snap head is 0.8 D. So for that, before drawing that snap head, you need to draw the radius. For that radius, you need a particular center. So I will tell you how to draw that center. So first you have to take the height of the rivet head. The height of the rivet head is 0.7 D, that is 12.6 mm. We got it as 12.6 mm, that is 0.7 D. 12.6 mm, you draw a line here. Then this length is, you have to take 0.8 D. So this is the half of the half portion of the snap head. The 0.8 D will become 14.4 mm. You draw 14.4 mm here. You draw close. So for this, now you have to draw the bisector for this and this. For drawing the radius of the snap head, you have to take the bisector of this line. So bisector of this line you have to draw. So I will draw like this, bisect this line. So this is the bisector of these two lines. These 2 points are the bisector of the line. Draw this line till it touches this center line. This is the bisector of this line. You have to reduce this bisector till it touches the center line of the rivet. This is the center line of this rivet. So extend till here only. So you got a new center here. So with this center, now you have to draw the arc. This is your center, and radius equals to 0.8 d. Radius equals to 0.8 d, that is 14.4 mm. Your 14 point radius is here. This one I have already drawn. So you have to draw an arc now. So this is the procedure for drawing a snap head of the rivet. So this is the diameter of the radius of the snap head. So you got these are construction line. Remove it. Similarly, you have to draw the top snap head. So for that also you need to draw the construction line. So instead of drawing this snap head in the bottom portion, I will tell you how to draw it easily. You just measure this distance. We need this center only. So your radius we already know. So we just need the center here. So that's why this dimension remains same for the bottom portion also. So that you just copy the distance from this line to this center. So similarly, you have this line here. You whatever the dimension will come here, you leave here. So that will become your new center for drawing the bottom portion of the snap head. So measure this dimension. This dimension is 1.91 mm. So you draw a line here from this portion, 1.9 and 91 mm. So draw 1.91 mm. Yeah, this is your new center now. So you will get this center by drawing similar procedure what I would draw here, by giving by allowing this height, and by leaving this as 0.8 d and bisecting this line. So you will get this same point. Instead of doing those these are lengthier procedure, so just copy this dimension from here to here. Since this both dimension remains same, so the same distance will come here. What you have maintained here, so the same center will come here. So that's why just you can copy here this distance and you can leave here. So now you got the new radius from this center, this as a center, and the radius equals to 0.8 d, that will be 14.4 mm. So you have to maintain a 14.4 mm radius here to draw a arc. That will become the bottom portion of the rivet head. This is about the front view. Now you can remove this. Okay. Now you draw the top view for this. You will get two lines here. Since we are in taper line here, you will get two lines. Similarly, you get two lines here. Now the first rivet we can draw in any portion. Now these lines are not required. Remove these lines. These are construction lines. Now you can start in the top view, in the first portion, anywhere you can start. In this portion, anywhere you can start. I will start here. Vertical center I will draw here. Now you can see the two circles here. One circle of this shank diameter, another one is this snap head diameter. So project this to draw the circle for top view. This is your center, first circle of this diameter. This is your I think it is not proper in the dimensions. Center it is not taking proper. It is not taking proper center. That's why it is coming here. So for this, I'll do like this. See, now it is coming properly. So this is the diameter of the shank. One first circle. Another circle is this snap head diameter. The same center we draw. This section you have to take a little bit top, or you have to move this center a bit downwards. First circle is the diameter of the shank. Next circle is the diameter of the head. Here you can see only the head in the top view. First you can see the head. The shank portion is invisible. So we have to draw this circle in a dotted line. Make it as dotted line. Now you have to draw for a pitch distance. Pitch P is given by 3 times the diameter, that is 50. We got it as 54 mm. So now you have to draw leave a distance of 54 mm. So leave a distance of 54 mm. 54. This is your new distance. This distance is pitch, that is given by the formula pitch P equals to 3 times the diameter. This is the distance for new center. So here say similar 2 circles you have to draw. Circle diameter, shank diameter is 18 mm. So another circle you have to draw. With this the dimension is not known, better to extend project this. Another circle. Okay. Now the third rivet, again you have to leave a gap of pitch P, that is 54 mm. So I'll offset 54 mm here. Draw 2 circles. First diameter is diameter of the shank, that is 18 mm. Another diameter is diameter of the snap head. I'll project. So this and these holes are invisible, so make it in dotted lines. Here centers, vertical center. We have 3 centers here. Since we are showing the section, so I have to hatch this. These are both different load plates, so that's why you have to hatch in a different angle. Different plates, so that's why you draw it in a different angle. So next you have to complete the bottom portion. you extend this. Now you extend this. The remaining portion you erase it. Erase the construction line, so not required. This is the center line, make it as center line. So these are the vertical center. So now you can give the dimensions. So this dimension is from center of the rivet to the end of the edge of the plate, that is 27 mm, 1.5D. So the thickness of the plates is 9 mm. This is 9 mm. You can see here, this is 9 mm. The diameter of the rivet head, that is 18 mm. So here to here is 18 mm. You can see here 18 mm. So next pitch P, that is 54 mm, 3 times the diameter. That distance is 54 mm from here to here, 54 mm. Similarly, from here to here is 54 mm. So this completes the single riveted lap joint with the 3 rivets. You can see here. So this dimension is D is 18 mm. This distance from the center of the rivet to the margin edge of the plate, that is 27 mm. Here you have to leave a gap, allowance of 10 degree here, both sides, here and here. And thickness of the plate is 9 mm. And the pitch P equals to 3 times the diameter, that is 54 mm. And this is the diameter of the rivet head. The diameter of the rivet head is that is 0.8D. The radius will be 0.8D and the diameter remains 1.6D. You can measure the radius here. This radius is 14.9 mm. 14 point you got as 14.4. So in the problem you got it as 14.4. So this radius is 14.4. This radius is 14.4 mm. The height of the rivet head is 0.7D. The height of the rivet head is 0.7D, that is 12.6 mm. This distance is 12.6 mm from here to 12.6 mm. So this diameter, this radius is 14.6 mm. The center is here, so you have to draw it by bisecting these two dimensions. From here to here you have to draw one line, and from here you have to draw another line. From these 2 points you have to draw the bisector, which will join, which you have to extend till the center line, and there you got the new center. From this center you have to draw a arc of a radius equals to 0.8d. The similar procedure you need not to follow here. Just you have to measure the distance from this to here, how much distance you got here. The same distance you have to leave here, and from that center you have to draw this radius. Otherwise it will require more time to draw this radius for the riveted. Thank you. So please follow it and please see, watch it fully, and if you have any doubts, please let me ask. Okay. Thank you all.